In this tutorial, we're going to talk about mid-segments in triangles. And in order to discuss what they do, we first have to know the definition of a mid-segment. And so what a mid-segment is a segment that connects the midpoints of two sides of a triangle. So let me show you what this looks like in a picture. Let's take this triangle, for example. We're going to call this triangle ABC. And we're going to go around the circle and find all of the midpoints. So I want you to look at segment AB. If I were to cut that piece right in half, in other words, bisect it, or find the midpoint, let's say it's right here. Okay, I have to estimate because I don't have a correct measuring device with this, but this does look like it's about halfway in between, and I'm just going to call it X. So this would be a midpoint of that side. This is a midpoint of segment AB. Not a mid-segment, it's a midpoint. So just to make sure that we clarify, let's go ahead and write midpoint here. Let's go and find the midpoint of side BC. So side BC, if I were to cut that in half, we'd be at about this point right here, which we will call Y. Once again, this is a midpoint, not a mid-segment. And on the bottom, on AC, if I were to connect those two, it looks like it would be about right here is the very middle, which we will call Z. Once again, midpoint, not mid-segment. So how do we get these mid-segments to come about all of this? And the answer is that we connect these midpoints. So when I connect X and Y like this, that is a mid-segment because it connects the midpoints of two sides of a triangle. I could also have another mid-segment from Z to Y right here. And I could have a third one from here to here. And what's really interesting about all of the mid-segments of a triangle is that it creates four congruent triangles. So in other words, this triangle is congruent to this triangle, is congruent to this triangle, is congruent to this triangle. So what's really cool about this is after I connect all of my mid-segments, I get four congruent triangles. And that's another theorem in your book, although I'm not sure which one it is, but it's there. So this is the very first thing that we're going to know about all of these mid-segments. And the next thing is we have a theorem in your books. It does have a special name. And so the theorem that we're going to talk about is Theorem 5-1. And it does have a special name called the Triangle Mid-Segment Theorem, or TMT, if you want to make an acronym. And the exact definition of this theorem is on page 260, but I'm just going to show you what it means. And this would be a great theorem to add to your theorem and postulates pages, so please make sure that you do that. So what this theorem says is we've got two interesting things as well as the four congruent triangles. And the first thing that we want to know is that all of these mid-segments, let's take segment, let's erase some of these real quick so we can just focus on a couple. It's not the best eraser in the world, but what are you going to do? Okay, so let's just create one mid-segment. Let's just talk about this guy right here. And I'm just going to fix the others. And what we know, because of this as being a mid-segment, is that it's parallel to another side of the triangle. So this mid-segment is parallel to another side of this triangle, and it's obviously not going to be side BC nor AC. It's going to be parallel to AB. And that's true for every single mid-segment. So if I were to create another mid-segment, let's say this one, this would be parallel as well. I'm just going to use open triangles for this one. This side is parallel to this side. And last but not least, this mid-segment here also is parallel. This one gets 3 triangles to this side over here. And remember that the reason why it's important to understand where there's parallel lines is to find alternate interior angles, alternate exterior angles, same side interior angles, corresponding angles, all of that good stuff to help us prove triangles are congruent and to know what's going on in general. Now, the next cool thing about this theorem is that it also says that a mid-segment's length is half that of the side that it's parallel to. So in other words, if this mid-segment had a length of 5 units, then side AB would have a length of 10. It's double as big. Or if my side AB had a length of 50, how big do you think the mid-segment would be? Take a guess. And if you said 25, you would be correct because it's half the length. So you can hopefully start to see if there might be some problems where you solve for variables. Let's take a look at an example. So let's say that this is my triangle, and I know that my mid-segment is 5x, and side AB is 70. How do I set up an equation? Because I can't say that 70 is equal to 5x, because that's not true. I do know, though, that this piece here is equal to 5x, and this piece here is also 5x, because AB has to be twice as big, or twice of the 2 x's, or the 5 x's, I should say. So you can go about this one of 2 ways. You can set up an equation like this. You could say, let's see, that would be 70 is equal to 2 of the 5 x's. In other words, 2 of those mid-segments, and that's true. Or on the other side over here, I know that half of AB will be equal to 5x. So I could say, let's see, it's half of 70, that's 35. So that would be equal to 5x. So if you look at these 2 equations, please take a minute to see that they are in fact the same exact thing. And it just depends on your own comfort level as to which equation you decide to use. And there's no right or wrong way to do this. And then of course, let's go ahead and solve these, and we should get the same exact answer. So on the left-hand side, we're going to say 70 is equal to 2 times 5x, which is 10x, and then divide both sides by 10, and that gives me 7 is equal to x. So when I plug in x, or 7 to x here, that would be 5 times 7, which is 35. And that confirms what we have over here on the right-hand side in my other equation. Because half of that should be 35 units, this guy right here. So if I were to solve for this, I would divide both sides by 5, and 35 divided by 5 is 7, so I get the same thing here, and we are good. So that's one way that you can see how to use mids. And that concludes this tutorial.